The electric power system has been described as the largest machine built by mankind. Almost everything that you see today is interconnected through a network of electrical wires that are managed in a very systematic way. Hi, I'm Sunil Charan, CEO of Spirae. We are located in Fort Collins, Colorado, and we develop control systems for the electric power grid. The electrical power distribution network has been operated in much the same way for the past 100 years. That situation is changing rapidly. Today, energy can be produced much closer to the point of use. Photovoltaic arrays, geothermal systems, wind turbines, electric and thermal storage systems, they're all moving closer and closer to the end user. That is part of the big transformation currently underway, from a few large generators connected to the transmission network to a very large number of smaller assets of all different types, all being added into the distribution network. We are moving from a passive distribution network to an active one. When we say smart grid, we are talking about the set of technologies that will enable this transformation, bringing new service options to consumers. Spirae develops smart grid technologies for operating the electric power system in more intelligent ways. Our product is a distributed control system that augments a utility's existing grid management system to dynamically manage large amounts of distributed energy resources. This approach matches up very well with the idea of decentralized energy. Just like internet-connected devices, these distributed energy resources have to work together across the electric grid. But we also need to make sure that as their numbers increase, they don't cause problems for grid operations or disturb the quality of power delivered to consumers.
Distributed through the yard to different sections of the 60 kV.
It's like asking you to change the tire on an SUV that's going down the highway at 75 miles an hour. You cannot shut down the power system, make significant changes, and then restart it. Instead, you have to isolate small portions of the grid, creating an electrical island. Then you're able to test new solutions and then connect back to the larger electrical system. Islanding portions of the grid without blacking them out is a challenging task. It requires local energy sources that can quickly supply customer demand. Reconnecting back to the grid is like getting a small wheel to spin at the right speed relative to a larger one, so that there is no shock or impact when they touch each other. In the electrical system, you synchronize the two sides by matching frequency, phase, and voltage. As we look ahead into the next 20 years, we're going to see photovoltaics on every rooftop, electric vehicles in most garages, and smart appliances in every home that dynamically respond to grid conditions. That's the type of distributed energy that's coming into play. And control systems such as Spirae's will be the glue that binds it all together. One of our North American projects addressed the challenges that transmission and distribution operators face as they bring more wind power into their network. They want to use distributed energy resources to smooth out problematic variations caused by intermittent production such as wind and solar. Another project attempts to connect market activity from the transmission end of the system all the way down to smart appliances. It's probably the most ambitious effort to closely link energy markets and grid operations, and Spirae sits right in the middle. And in Southern California, the issue is large amounts of photovoltaics that are beginning to impact grid operations. We address these problems by essentially augmenting brawn with brains, minimizing the need to make physical upgrades to the grid. Denmark is a very progressive country when it comes to renewable energy and sustainability. Their goal is to transform themselves into a carbon-neutral economy by 2050. Today, about 25% of their electricity is generated from wind power. But they're also reaching the limits of how much new renewable capacity can be added to their power system. Energinet.dk is the electric and gas transmission system operator for Denmark, tasked with keeping the electric grid in balance and developing technical and market solutions. Energinet is one of Spirae's major customers, and we've been working with them for several years to develop and demonstrate sophisticated grid management solutions. We successfully demonstrated how distributed energy resources such as wind, combined heat and power plants, and load management could all be used together to reliably operate the grid.
How do you know what is going on at all levels of the power system is a monumental feat.
Instead of having production of electricity placed in one place like we used to do in Denmark, we had small plants, and that helps us make production where you need it.
Spirae is demonstrating that this is technically feasible.
As we're developing, we certainly don't want to take risks with the grid.
We had to demonstrate the operations of the system in a realistic software simulation ahead of time.
It gave me sort of a sandbox to play with.
The real part for me is especially when we island.
Islanding is the process of separating a portion of a power grid from the rest of the grid.
The main breaker snapping open, and poof, you have to keep the system in balance and run it.
Because it's not only enough to have the right production, you have to have the production and the right voltage.
This is our RTU, a remote terminal unit. In here we wrote the software to do all the synchronizing. We're actually synchronizing over a communication network.
It worked as we expected it to work.
The same capabilities used for running a local region in island mode can also be used to increase the stability and reliability of the primary grid.
Of course, anytime you see any of your concepts and controls being brought to light and functioning the way they're supposed to, there is an enormous amount of pride that goes with that.
Now we have this tool, this ability to sort of estimate values all over the power system and bring them back into the cell controller.
If you have multiple sections or cells and you coordinate all their operations, you're really transforming the way in which you're controlling a very large grid.
And as we move towards this new power system of the future with distributed generation, with lots of different renewables integrated in it, that still has to be maintained.
We expect these technologies pioneered in Denmark to become mainstream as the smart grid matures around the world. Cities, municipalities, and innovative regional initiatives are taking the leadership in defining what they want their energy future to be. They literally serve as a catalyst for pulling all stakeholders together. A few years ago, there was a community initiative in Fort Collins, Colorado that resulted in a project called Fort Z, short for Fort Collins Zero Energy District. The idea was that downtown Fort Collins and a good portion of Colorado State University campus could be turned into a net zero energy district by producing as much energy as it consumes. The initial phase of Fort Z was kicked off with a project funded by the US Department of Energy through its Renewable and Distributed Systems Integration program. This project demonstrated how the loading of distribution feeders could be managed proactively using building control systems, backup generators, photovoltaic systems, and smart chargers for electric vehicles. About 5 megawatts worth of resources came from city and county buildings, the New Belgium Brewing Company, Colorado State University campus, and the Intergrid Lab. At New Belgium Brewing Company, effluents from the brewing process go into an anaerobic digester producing methane. This methane is then used to power an on-site power plant, generating both electricity and heat.
In the end, the ultimate goal is to reduce the feeder peak on the Linden substation 20 to 30%. We're able to talk back and forth and turn things on and off when they request them, and it seems to work well. And I'm hoping that this is going to spur a lot of smart grid around the country.
One of the things that Spirae is very involved in is in developing initiatives with cities that want to become smart cities. We bring a lot of these capabilities together from a community's point of view. We are very excited about playing a key role in these initiatives, and we expect to see a lot more of them in the future. With the growing number of smart grid initiatives that are getting underway, one of the challenges that the industry as a whole faces is the shortage of power engineering expertise. We have to strengthen our training program substantially to cross-train new hires from other industries before they can become effective in our domain.
We have to develop our own workforce. It's very difficult to find people with a skill set that includes exposure and experience in all of those areas.
Since this is an issue facing the entire smart grid sector, we launched a new initiative called the Center for Smart Grid Advancement, directly targeting this gap in the market.
Concentrating those efforts that we're doing anyway and formalizing them through this center.
We are working very closely with several educational institutions to develop professional training programs in this area.
What is unique about the courses that we're going to deliver through the Center for Smart Grid Advancement is the hands-on component. Short-length, concentrated courses. They can see the with controls and the without controls and make comparisons so that, in fact, you can realize the benefits of the smart grid. We're really trying to teach that system view.
Other stakeholders in the industry also face exactly the same impediment. Utilities, technology companies, regulators, all are experiencing workforce challenges.
We envision being able to build an infrastructure and education and training that supports that same stakeholder group. The smart grid transformation is all about change. And to get to the change, people have to get it, both in their minds and kind of that, the hands-on piece, and also kind of in their hearts. They've got to understand and feel what's possible.
Testing new concepts and technologies for grid operations is a very difficult thing to do on a real power system. But if all your tests are limited to software simulations, then you have no idea whether they'll actually work in the field. That was one of the motivations for Spirae to develop the Intergrid Lab, where we can mimic a portion of a real distribution network. This lab is located at the Engines and Energy Conversion Lab at Colorado State University. It's a multi-megawatt facility where new equipment, technologies, and concepts can be safely tested. If tests don't go as planned, well, we black out the lab and try again until we succeed. Once new technologies are proven out, they can then be implemented on real power systems with a much higher degree of confidence. Very advanced R&D can be done at the Intergrid Lab. It's the proving ground for our technologies. Spirae's technologies will, for the most part, be invisible. We enable the synergistic integration of many technologies, regardless of who built them, so they may work together to enable new business models. Bringing the benefits of a diverse array of distributed resources to different markets is one of the fundamental challenges of smart grid. The underlying problem is that you need a control system that actually manages these dynamic resources in concert with grid operations. Spirae's Bluefin platform is designed to serve this need. It brings together deep technical capabilities in power engineering, modeling and simulation, software, and applications engineering to realize the many benefits of smart grid. If we can play a key role in the transformation to large-scale renewable energy distribution, that will be both professionally and personally fulfilling. We want to be the glue that bound it all together at the end of the day.